Okay, before we start milestone one, I think as I've been sort of working with other students and reviewing things, there's sort of a shift between students that remember material from third quarter and students that really didn't absorb certain material for third quarter. So, in order to do a short milestone one video, you need to remember how ions work, how atoms form cations, and how they form anions. If I am going to attach to this assignment a review of that, but you can try and follow along. If you get lost, then it probably means you need to watch the extended video and and watch that, understand ions, and then jump back in. So naming ionic compounds, if you can remember what we did during third quarter for ions, should be pretty straightforward, right? So you need to be able to remember that metals form a certain type of ion called a cation, and you need to be able to remember how to find the charge of cations. And then you also need to remember that nonmetals are going to form anions, and they're going to have a certain charge. We're going to throw transition metals into it, but that just builds off of cations. Okay, so remember metals in this first two columns, right? First column has one valence electron, second column has two valence electrons. Third column has three valence electrons, fourth column has four valence electrons, fifth column has five, six, seven. These are noble gases. They have eight, right? And they are stable. Exceptions are helium and hydrogen. Hydrogen has one valence electron. It only has one energy level, so it cannot hold more than two electrons like helium. Helium is stable, only has two, doesn't have eight. All right. So metals form cations because they lose their valence electrons. Nonmetals form anions because they gain valence electrons. The goal being to get to the stable configuration. And you should be able to explain why that is, but you can also watch the video. I'll explain all that in detail. So you should also understand if it has one valence electron and it loses one, it ends up with more protons and electrons and a plus one charge. Second column, plus two charge, plus three, plus four. Now when we get to the fifth column, it is easier to gain electrons because of electronegativity. So in that fifth column, it's going to gain 3 electrons to get to 8. It's going to gain 2 electrons to go from 6 to 8, 1 electron to go from 7 to 8. Then you end up with, in these cases for the anions, you end up with more electrons than protons and an overall negative charge. Okay? All right, so that's the short review. If that was too much for you, then you need to watch the extended video. All right. So naming ions is pretty straightforward, right? We take the element name, we add the word ion if they're a metal. Okay, so lithium becomes lithium ion, sodium becomes sodium ion, beryllium becomes beryllium ion. You also need to be able to understand the charge, and that's for when we do the chemical formula. Some nonmetal examples, right? Fifth column, nitrogen gains 3 electrons when it forms an ion. The difference for nonmetals is we change the end to IDE, right? So phosphorus becomes phosphide ion. Oxygen becomes oxide ion. Chlorine becomes chloride ion. Okay, so I left some blanks for you guys to practice and include in your final resource. That's where those question marks are. Now let's look at transition metals. We talked about electron configuration with transition metals. You'll remember this is our D block, right? What happens is in the D block, my energy levels when I start to get to D, right? So my first energy level just has one orbital. My second energy level has 2 orbitals. My third energy level has 3 orbitals, right? The first is just S, holds 2 electrons. Second has S, but it adds P. S holds 2, P holds 6, that gives me 8. Then we get out here to the third energy level, S, P, and now we add D. Okay? Then the fourth energy level, right, adds F. So then we end up with you guessed it, S, P, D, and now F. Okay, right? So that's energy level 1, 2, 3, 4, right? So we keep adding those. So as we add these, and these letters are our orbitals, right? So they can hold more and more electrons the further they get out. The distance between them gets shorter. As the distance gets shorter, electrons move around to different orbitals. So transition metals, what makes them special is when they form ions, they can form ions with different charges depending on them, right? And it has to do with that. We refer to them as having different oxidation states, which is just a fancy word for saying that the electrons can jump around more. So if I look at transition metals, right, iron is an example. Iron can have a +2 charge or a +3 charge. So when we're naming them, we add these Roman numerals to indicate the charge. So iron and then 2 in parentheses. Copper with a 2 in parentheses. Does that make sense? Right? So that represents the charge. We don't need the word ion because the parentheses and the Roman numerals already indicate the ions. Okay. So now we know how to name all 3 sections on the periodic table. And this is just for ionic compounds. So this is when a metal and a non-metal come together. So if they have a group 1 or 2 metal coming together with a transition metal, for example, I'm going to take the name of I'm going to start with the metal, then I'm going to name the non-metal. So it's calcium, and then we change the N to IDE, so chlorine becomes chloride. Okay, so I go to calcium, chloride. All right, so if I had sodium and chlorine, it would be sodium chloride, which is salt. If I had magnesium and fluorine, it would be magnesium fluoride. Okay, so we just add that IDE. All right, the next video I'm going to do will give you guys a review of how to do this charges, how to come up with this. And then there'll be a third optional video for people that need a more in-depth review of ions in general.